There is a certain rhythm to technological progress that we all come to expect. When a major company releases a new model, we anticipate a step forward. We expect better reasoning, faster responses, and greater reliability. For a long time, the team behind these large language models built a reputation on delivering exactly that. They were the standard against which others were measured. But recently, something changed. There is a growing consensus among developers and engineers that the latest iteration, Opus 4.7, represents a significant departure from that standard. It is not just a minor update with a few tweaks. It feels like a fundamental shift in how the system handles pressure. Here is the thing that is causing the most alarm. It is not about the model getting answers wrong occasionally. Everyone knows that these systems are probabilistic. The real issue lies in the infrastructure that delivers those answers. Under high concurrency load, the API latency spikes in a way that breaks the very pipelines built to use it. For the average user, this might look like a slow response time. For the engineers building automated systems, it is a catastrophic failure of their data pipelines. When you are relying on an asynchronous data pipeline, you are building a sequence of events where one step must complete before the next begins. If the model takes too long to respond, the entire chain halts. Imagine a busy highway during rush hour. In the past, the road handled the traffic smoothly. Cars moved in a steady stream. Now, imagine that every time a certain number of cars entered the road, the traffic lights would turn red for everyone for 10 minutes. That is what is happening with the API latency. It is not a consistent slowdown, it is a spike. One moment the system is responsive, and the next, it becomes unresponsive for a critical window of time. This is particularly dangerous for systems that depend on real-time data processing. If your application sends a request to generate a summary, and that request hangs for 30 seconds, your application might time out, drop the connection, or worse, process stale data that it thinks is new. Now consider the specific technical issues that have been documented by the community. There are reports of critical failures with the Amazon Web Services Bedrock integration. This is a major platform for hosting these models. When the integration fails, it is not just a glitch. It means the connection between the developer's code and the model's brain is severed. Developers have reported incorrect thinking formats when reasoning is enabled. This means the model is generating output that does not match the expected structure, breaking parsers and downstream logic that expects a specific format. It is like a chef who knows how to cook but keeps serving the food on the wrong plate, confusing the waiter who is trying to deliver it to the table. The community's sentiment has shifted dramatically. Where there was once excitement about the new capabilities, there is now a sense of doomerism. Users are expressing that the company has failed to meet quality standards. This is not just about a single bug report on a forum. The widespread consensus across GitHub issues and Reddit suggests a systemic release failure. It points to a disconnect between the model's development and its deployment readiness. It seems as though the internal safety warnings about the release were not heeded, or perhaps they were not strong enough to stop the launch. The result is a product that feels like it was pushed to the market before it was truly ready for the weight of production environments. To understand why this matters, we have to look at how these models are integrated into business logic. Most companies do not use these models as a chat interface. They use them as an engine behind the scenes. They are feeding them data, asking for analysis, and expecting a structured output to be fed into another system. This is the world of async data pipelines. When the model performs well, the pipeline flows like water. When the model degrades, the pipeline floods. The latency spikes cause timeouts. The hallucinations cause incorrect data to be written to databases. The broken output formatting causes scripts to crash. All of these issues compound. A single error might be recoverable. A systemic release failure means the entire architecture is at risk. There is a deeper implication here regarding the development process. When a model is released, there is usually a period of testing. But it seems the testing did not cover the specific conditions where the system is most likely to fail. High concurrency load is a common stressor. It simulates what happens when thousands of users interact with the system simultaneously. If the system cannot handle that load without spiking in latency, it is not production ready. The fact that this was not caught before release suggests a gap in the quality assurance process. It suggests that the focus was perhaps placed on new features rather than on the stability of the existing core. This is a critical moment for the industry. Reliability is the currency of trust. Once a user loses trust in the stability of a tool, they look for alternatives. They migrate to other providers, or they build their own internal solutions. This shift in sentiment is not just about frustration, it is about risk management. Companies are now asking hard questions about whether they can rely on this model for critical operations. The fear is that if they build their workflow on top of this, they are building on sand. The latency spikes are the warning sign. The broken formats are the cracks in the foundation. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.